So in this class we will see the sign conventions, okay, or the new Cartesian sign conventions for mirrors. This is absolutely important if we're going to do the numericals in this chapter light, okay, with ease and without difficulty. So let us do that. Now the question here is the question number 36 on your tuition note, okay. You'll find this on page number 95, this question, if you want to refer to your tuition note later. But even then, even if you have one tuition note, you will also write it down. Okay, so let us divide your about half or a little bit less than half of your notebook into two parts, right and left. Okay, and then let us use this side concave mirror for representing concave, and on the right side let us use for representing your convex mirror, let us say. Let's do slowly because this is, I feel, very important. In fact, the most important thing that you need to get, okay, before doing any numerical on light. Okay, so reflection especially. So if on the left side, let us draw here a representative concave mirror line, and then on the right also you draw the line. Okay, and then we know now by now how to draw the concave mirror, and I have keeping here a concave mirror and a convex also to make us understand. So this is concave, means like the inside of the spoon carving inside is the reflecting surface, and this blue side, which from where you can't see your face, is the non-reflecting surface. So first sign convention is this: we must put our mirror, so put your C on the left and take around 6 centimeters and take the center of your compass like this and draw an arc. So that will represent like this. First sign convention: the reflecting side must face left, so that the object is on the left, like I am the object, my face is on the left. We know we can use like this also with the reflecting surface facing to your right, and my face, the object, is also on the right. In real life we can do that, but here we are following convention. So the convention is we won't do like this, we will do like this, so that the non-reflecting side, blue side, which is denoted by oblique lines, is on the right side, and the reflection side is on the left side. This is the first sign convention. Okay, so next, mark the middle point of your mirror. That is called pole, and half of 6 is the focus. So mark those things. Now here let us draw an object. So that is the first sign convention: reflecting side of mirror must face left side, just like we have drawn now, and the line, the oblique lines here, which is the non-reflecting side, on the right therefore. So because of this, the object must be placed above principal axis like this. Okay, the first sign convention is mirror facing left, and object must be perpendicular and above the principal axis like this. Let us say this is your object therefore. Okay, so placed above principal axis and left side of the mirror. See, the object is on the left side. See? Okay, so that is the first sign convention, this one. Okay, then next, let us draw a ray parallel to the principal axis starting from the top of object. We already know this incident ray. First ray is called incident ray. After striking mirror, you know it will bounce back, reflect, because mirror, the only job is to reflect and go to the focus. So that is the reflected ray. Okay, then look here. I will draw here. Now if you go to question number, formation of image by concave and convex mirror, question number 26, which is for formation of, question number 24 of your previous classes we have done, formation of images by concave mirror, you will see that all real inverted, case 1 to case 5, all were real inverted image and you found out that all of them were on the left side like this. You never see a real inverted image, let us denote by RI, on the right side. So we know that from our question number 24, when we did that for formation of images by a concave mirror. So this image here will represent all real inverted image, which is on the left side of the mirror. This is the mirror, so left side, and this is the right side of the mirror. And then case 6 of question number 24, when object was placed between P and F, we saw that an image was formed. That is the only case when the image was formed behind the mirror and the image was taller than the object, bigger than the object, and that was virtual erect. So we saw in question number 24 that virtual erect image was always from right side or behind the mirror. Real inverted was always from real or left side or in front of the mirror. I am repeating again. Virtual erect image was from behind or right side of the concave mirror. Real inverted image, every one of them was from in front or left side of the mirror, because that is the key thing in solving numerical. We need to know real inverted is in front and virtual erect image is always behind mirror if you're going to do the numericals properly. Okay, now here let us measure one distance here. This distance between P and then the image, this is the virtual erect image, is called the image distance. How far the image is from the mirror is called image distance V. Okay, then this one here, let us take this one. Distance between here P and F. Between P and F is called focal length, small f, we know that the distance. This point is focus, but the distance between P and F, we have learned in our previous class, is focal length. Then the distance between this real inverted image and this one here, you also mark it likewise, is called image distance, V. Then here, so here you see, and then one more is here, distance between C and P. All distance measured between from P, okay? So here, C and P. This distance between C and P is called radius of curvature, right? We have learned this in our previous classes. Then the distance between the object, this object here, and the mirror or pole is called the object distance. How far the object is from the mirror is called object distance, U. See, if I'm standing in front of the mirror, I'm the object. So the distance between me and the mirror is called object distance. Okay, the distance between the mirror and the image is called image distance V. So we see this one. Now, the next sign convention is like this. That all distances like F, small f, V, V, R, and U, which are parallel to the principal axis, the line passing through P and C is called principal axis, or which are actually on the principal axis, will be measured using P as the starting point. That's why starting point or origin. So here all distances on or parallel to principal axis will be measured always with P as the origin, means starting point. That means P will be your origin, means starting point 0, 1 centimeter, 2 centimeter, like that we will measure. This distance here will measure from here 0, 1, 2, 3. So 0 should always be on the P when you measure with your scale. 1 centimeter, 2 centimeter, like that. That's the meaning of origin. Origin means starting point 0 should be from pole and you'll measure. That's the second sign convention. Okay, the third sign convention. Write down these two and then come to the third sign convention. The third one is all distances on the left of origin. Okay, left of origin means P. Left side of P are taken as negative. Okay, is taken as negative, and on the right side. It means right side of origin are taken as positive. That is very important now. Let us see what does this mean. So here, if you look at this one, this V is measured on the right side of P. So V will be plus when it is virtually erect. And this V here, the other one, is measured on the left side of P. So V will be minus when the image is really inverted. Here F, focal length of this concave mirror, is measured on the left side of origin P. So F of concave mirror is always negative. R, capital R of concave, is also measured on the left, so always negative, radius of curvature. Object, whether concave or convex, will always be negative because we cannot put an object behind the mirror. This side will not reflect. So that's why it's always left side. That's why you must always get negative, because the first sign convention itself says that object must be placed in front left side of the mirror. Okay. So that is the sign convention for distances that are parallel to the principal axis. But there are also distances here. Okay. Another type of distance, some are perpendicular and above principal axis like this, which is here. This one is called object height HO. So any distance measured above, these are all parallel but now above principal, perpendicular and above are taken as positive. Okay. And all distances above and perpendicular principal axis, this is image height, object's image size, positive. And all distances below principal axis like this one, which is the image, so image height HI below principal axis, are taken as negative. So let us write that down. The fourth side convention. All distances perpendicular, all distances perpendicular and above principal axis. Principal axis is the straight line passing through C and P. This one, principal axis, are taken as positive. And below, perpendicular and below principal axis are taken as negative. Okay. So with these 3 and 4, we can get now here all distances, look here, that are measured on the right of P are positive, on the left of P is this middle point, are negative, above the principal axis are positive, below principal axis are negative. So this is the simple meaning of the sign convention. Therefore, we see that this sign convention for mirrors are very similar to your graph paper, where we draw here one vertical and one horizontal line, x dash, y dash, and we know that while plotting also on the right side are plus, left side minus, above is plus, below is minus. So it's quite similar to this graph Cartesian when we draw graph paper, right? When we draw graph on a graph paper. So that is why this mirror sign convention is also called new Cartesian, because Cartesian means the graph paper rule. Okay, graph rule, Cartesian sign conventions for mirrors. Okay, now let us go and do here one more thing before we go any further. Now remember this, m value is given as, basic formula is hi divided by ho, image height by object height. So there will be 2 m value for concave. Why? Because it can form both type of image, virtually erect and real inverted. So when it is virtually erect, m will be what? Let us see. M will be, when it is virtually erect, m will be, hi virtually erect is plus, so plus by HO is always plus, so plus by plus. So HI by HO will be plus by plus, so M value will be plus when it is virtually erect. Then how about second one? Second possibility also, the real inverted, because concave mirror can form both types of images, virtual erect on the right side and real inverted on the left. So here, when it's real inverted, HI here, see, is minus. HO is plus, or minus by plus will be. So M is negative. M is negative when the concave mirror form real inverted image. Keep that in your mind, okay? Now, so that means M will be minus 1, minus 2, or minus 2, minus 3, like that, if the image is real and inverted, okay? So let us do for convex. Like we did, the same rule, reflecting, this is now convex. Concave was inside spoon is reflecting, but this side, outside, bulging outside is reflecting. So that also should face left, just like concave. So if the curve is like this now, then we have to draw the center this side, no? And draw like this. Take your center of the compass here, and then now you draw here. You draw the curve like this. Then mark the non-reflecting side this side. As we said, reflection side should face left, so convex also same. Okay. Now at this point, I want to explain something to all of us. Look here. Here, this is C, okay, that's fine. Now, so do that. Now, some people draw like this, and then they make mistake. This is convex, correct? But they put C here. Now, think about that. That is impossible or not? Because the ball, all spherical mirror are taken out of a ball, like this. So, center of the ball will be inside, right? Center of this ball will be not outside the ball. So if you draw your C like this outside, it's wrong. So C should be, how do you search? Look at the curve. And the ball is like this. So C should be inside. Then you draw like this, then it's going to be wrong. This is correct because this is the ball curve. So the C will be inside the ball, right? So you please remember that. Now, just like the rule for concave, everything will be same for convex also. So here you draw the object. If you face the mirror left, then the object should be also on the left. So this is your object. As AB is your object. And then draw a ray parallel to principal axis up to the mirror. We forgot here, but this is your P, and half of this distance you took 6, then 3 you take and mark F. Then here you see, next is you put your scale here and here, and then remember what I'm going to say. On the left side, draw full line. On the right side, on the same straight line, draw broken lines like this. This whole thing should be on the same straight line. Then this ray will come and then bounce back like this, and it is coming from here, right? But after reflection, because of the direction, it will look as if it's coming from F. It is not coming from F. It is coming from the incident ray from left side, but it will look as if it is coming from F, which is on the right side. So this ray look as if, the reflected ray look as if it's coming from focus, but it's not really coming from focus. And if you go to the question number 29, where we did the formation of images by convex mirror, in both the cases you'll find that the image was virtual, erect, and diminished also on the right side, and never on the left side. So we found out that convex mirror could form only one type of image, and that was virtual erect on the right side between P and F. So only one type of image is possible for convex mirror. So virtual erect image on the right side, just like concave, virtual erect on the right side. So we now know that for any spherical mirror, the virtual erect is always on the right, whether concave or convex. Virtual erect cannot be on the left, okay? And now, what is the difference between a virtual erect for convex here and concave? Yes, that's right. The difference is here, the virtual erect is diminished. But for concave mirror, virtual erect is always magnified, okay? So keep that in mind. Again, I'm repeating, virtual erect images, we have found out that always form on the right side or behind mirror, but both concave and convex. real inverted image is formed only by concave, not by convex, and is always on the left side. If you remember that 2 points, you can do any numerical. Okay, so let us mark the distances now. So here, so we know this distance is same rule. So between image and the pole, then the distance of image from the pole is called image distance V, very clearly on the right side of P, so plus. So we will never get V which is minus for convex, because convex cannot form real inverted on the left. Every image is formed on the right, virtually erect. So V is always plus for convex, which means if you are doing numerical on a convex mirror and they ask you to calculate the value of V and you found out to be minus, it is definitely wrong, because V should be always plus, right? Then this is the distance of F, and P means small f on the right side, so plus. So we see now focal length of a convex mirror is positive, focal length of a concave mirror is negative because it's left side. Here it is positive because it's on the right side. Okay, so here distance between P and C, we know this is called radius of curvature. Clearly we can see it is measured on the right side, so this radius of curvature also will be plus. And the distance of the object from the mirror P is called the object distance U. It is always on the left, whether concave or convex. We cannot put object behind mirror, that way we won't get image. Always in front, that's why it's minus. Okay, left side. So these are the only ones. Then here, you see here, object is above principal axis, always, so HO is always plus. Whether it's convex or concave, the rule is same for this. This is called the image height, virtually erect, HI, always above, so plus. Therefore, we will never get HI minus for convex, because convex do not form real inverted image. Okay, so here, if we have done that, then M value will be only 1 for convex, that is plus, because it forms only virtual erect. See here, HI plus, HO plus. M can never be minus, because convex mirror do not form real inverted image. Okay, so those are the sign conventions that we need to keep in mind. Again, before we end the class, the main sign convention we need to keep in mind, apart from M, is this one. All real inverted images form on the left side or in front of concave mirror, or all virtual and erect images are formed behind or right side of concave or even convex, because convex can also form virtual erect images. Another point we keep in mind is concave mirror can form both types of image, virtual erect on the right side of mirror, real inverted on the left side of concave mirror, but convex mirror can form only one type of image, virtual erect, always on the right side of the mirror. Again, I repeat, real inverted image are formed on the left side of concave mirror, virtual erect on the right side of concave or convex mirror. Okay, if you keep that in mind, every numerical will be quite okay. So next class we're going to start the numericals, test 10A. Okay, so that concludes this class.